Hey, how's it going on, guys? So in this video, we'll discuss about this problem, sort characters by frequency. Given a string, sort it in decreasing order based on the frequency of characters. So let us consider some examples. So for this example tree, the output is EERT. Reason being E is present 2 times and R and T are present 1 time each. So EETR is also a valid answer. Let us consider one more example. So in this example, the string is welcome to my channel. So the output is something like this. Why is the output is something like this? The reason being the first character E is present the max number of times, that is 3 times. Then the second character C is present the second max times, that is 2 times, and so on. So how to solve this problem? Now the first thing that comes to our mind is what we can do is we can simply iterate over this string given to us and we can maintain a count array, that is the count of each character. Once that is done, we are left with something like this, correct? Now we know that for E we have 3, that is E is present 3 times. So this is the character which is present the max number of times. So we know that we have to process this character first. So what we can do over here is we can maintain a max heap of characters. And the polling scheme will be based on the frequency with which a character is present in the count array. So once that is done, when you poll from the priority queue for the first time, for the current example, we'll get something like E. Now in the count array, we know its count. So we know how many times we need to process E. So we can build our output string using this algorithm. So let me just write the code for this and then things will be more clear. So first is we have to check for the null case, that is in case s equal null or s dot length equal 0, you can return the current string. Next, you have to maintain a count array of size 256. Why 256? Because there are 256 characters present. Next, you will simply iterate over the current string. So s dot to char array, and for the current character, you will simply increment its count. After this, you will maintain a priority queue, that is a max heap of character. Let us name it PQ. So this will be new priority queue. Now here we have to provide the comparator because the comparison will be based on the frequency with which a character is present in the count array. So I can write a comparator over here or I can write a lambda function over here. So I'll do the lambda function over here. So this is a comma b and this will return count ARR b minus count ARR a. Okay. So after this is done, we have to iterate over 256 times. And I have to add in the priority queue the current character. Correct. So the character being added is based on the fact what is the frequency of it in the count array. Correct. So after this is done, we can simply create a string builder. Let us name it SB. And we will do something like while priority queue is not empty. So we can fetch the current character, which is equals to pq dot poll. So it will first give the character which is present the max number of times. Correct. Now we need to process this character how many times? It will be present in the count array. So what we can do over here is we can do something like for int I equals 0, I less than count ARR C I plus plus. So you can simply append the current character this many times. And after this is done, you can simply return sb dot toString. Okay, so I guess that's it. Let me run this code first. So it's giving the correct result. Let me submit the solution. So it got accepted. Now one more thing I want to point over here is, you might think that why are we using a string builder over here? What we could have done is, we could have done something like, we could have taken something like, say, string sb equals new string, and instead of sb.append, what we could have done is, we could have simply add sb plus equals c. That would have been correct as well. So what is the difference between a string builder and a string? Actually, if I would have used something like string, the complexity would have increased. Why is that? Let me show you something. So always remember that the strings are immutable. So let us consider one interview question, that is the reverse string given to you. So a string is given to you and our job is to reverse the string. So one of the method is, you can simply consider a reverse string, something like this, and you can iterate over it from the back side, and for each character you can just add it to the reverse string, and you can print the reverse string. So it looks like the complexity for this algorithm is on, but it's not. It is actually on square. Reason being, this is an on operation. Why this is an on operation? Because strings are immutable. So whenever you are adding a particular character to the reversed string, what's it's doing, it's creating a new string. So its complexity is on. That's why the total complexity for this is on square. And if you do the similar thing using a string builder, so in the second I've taken a string builder, and for each character I'm just appending it in the string builder, and I'm just doing this thing. So the complexity for this is on. So always remember that whenever you have to create a new string, use a string builder instead of string, because this operation is not on, this is on. So this would have increased the complexity. That's why we are using string builder instead of string. So I guess that's it from the video. In case you have learned anything from the video, you can hit that like button, and in order to support my work, you may consider subscribing to my channel. Thank you all.